We are going to use the DC machine block in order to implement as well as simulate our DC shunt motor. So in order to do that, we have to make sure that we have the Simscape library, and we can check that by going to library browser. You can see I have the Simscape library. So since I have the Simscape library, I just need to double click on my canvas and then type DC machine. So this option will appear. So I will click on it. So this is my DC machine block. Let me make it bigger. So you can see it has 6 ports. So the first one is the mechanical input. Then I have the positive and negative of the armature windings, and I have the positive and negative terminals of the field windings, and I have the motor outputs here. So if I double click on it, so I can choose the model I want to work with by clicking on this. So I have different models here. So I will work with the first one, which is a DC motor of 5 horsepower with an armature input voltage of 240 volts and a speed of 1750 rpm and a field winding input voltage of 300 volts. So I will select that. So there are different mechanical inputs. I can have the torque load, the speed, and the mechanical rotational force. So I will go with the input torque as my mechanical inputs. Then I will just apply and then OK. By default, this DC motor is designed to be a separately excited DC motor whereby the armature and field windings will have independent voltage sources. However, you can make it a DC shunt motor by choosing the same voltage source for the armature and field windings. So all I need to do is to double click and then type DC voltage source. So I have it here. So let me double click on it in order to write the voltage I need. So if you could remember, the model I selected has an armature voltage of 240 volts. So I will apply and then OK. So for a DC shunt motor, both the armature winding and the field winding will have the same voltage source. So that is for the positive terminal here. And I will do the same thing for the negative terminal. So by doing so, I will have a DC shunt motor. So the DC motor gives a number of outputs. So in order to know the output it gives, let me use a bus selector. So double click and then type bus selector. I will connect it to the output here. So let me double click on the bus selector in order to see the output the motor gives. So you can see it have like unknown signals here. Let me just clear them. So these are the outputs from the motor. I have the speed of the shaft, I have the armature current, the field current, and the electrical torque. So let me select my speed as the first output. So then just click on it and then click on select. You can actually choose them in the order you want. So if you want the torque as the second output, just click on it and then select. You will see it here. So I will want the armature current as the third and then the field current as the last one. So after doing that, I'll just apply and then OK. So you can see now I have 4 outputs here. So let me make it bigger. So in order to visualize my outputs, I need a scope. So let me double click on the canvas and then type scope. So this is my scope option. So now it has 1 intake, but I need 4 intakes. So let me double click on it. Then I will go to file, then number of input ports, then more. I will change 1 to 4, then apply, then OK. So you see now I have 4 intakes. For the viewing, let me change the layout. So I want the 4 outputs to be on different visualizations. So you can see I have 4 plots now. So now in order to connect the bus to the scope, I just need to click on the bus, then click on control, then click on my scope, and then the output from the bus will be connected to the scope. So for the final port, that is the mechanical input, which is my input torque, I need to use the specifications from my selected model for the calculation of the input torque. So this is my input torque calculation. I have the torque is just the power over the speed. So my power is in horsepower. So 1 horsepower is just 746 watt. So that will give me 3730 watt. So I need to convert my speed, which is in revolution per minute, to rad per second. So I use this formula and I will end up with 183.28 rad per second. So my torque, if I substitute the power and the speed here, I will be able to get 20.35 Newton meter. So now I need a step input. I'll just double click on the canvas and then tap step. So I have my step here. I will then collect it to the fourth. So if I double click on it, let me change my step time to 0. Then the final value here would just be 20.35, which is the computed input torque. So I will apply and then OK. So in order to run this simulation, I need the power GUI. So I'll just double click and then type power GUI. So I have it here. So now I am set for my simulation. So I will then click on run. After running, I just double click on my scope. So you can see I have my speed here, that is the shaft speed. I have my armature current, I have my electrical torque, and I have my field current here. For another comprehensive DC motor modeling and simulation using Simscape library, watch the video on the screen. Please like and subscribe to the channel. Thank you for watching.